This video illustrates a core tension in the modern enterprise. Business units are demanding the productivity gains of generative AI, but security leaders face a hard stop. They simply cannot allow unmasked corporate data to ever leave the environment. To bridge this gap, organizations lean on standard vendor agreements and business associate agreements, or BAAs, hoping legal contracts will keep their data safe. But a vendor opt-out toggle is merely an administrative promise. It is not an auditable technical safeguard that proves your data is protected. These administrative controls rely entirely on downstream trust. By the time a vendor promises not to train on your data, the unmasked information has already crossed the network and left your organization's control. Legacy data loss prevention tools were built to catch structured file transfers. They consistently fail to intercept the unstructured copy and paste behavior of an employee typing into a browser text box. That gap allows internal credentials, application API keys, and highly regulated customer data to flow freely into third-party cloud models hosted by OpenAI, Anthropic, or Google. The millisecond that toxic data reaches a third-party server, it triggers overlapping compliance violations across multiple global jurisdictions. To achieve actual compliance, organizations must replace downstream administrative trust with an immutable upstream technical control. This architecture diagram details the solution. We shift the security perimeter away from the network edge, collapsing it inward to form a tight boundary directly on the local workstation. This mechanism is called Zero-Trust Data Sanitization, or ZTDS. ZTDS operates 100% client-side, executing specifically inside the volatile RAM of the user's browser. Data is halted precisely at the point of prompt, before the browser can even generate an HTTP payload to send over the network. Inside this volatile memory, sensitive identifiers are mathematically swapped for localized, anonymized placeholders. Because processing occurs in volatile RAM, the sanitization matches the speed of the user's typing, avoiding the latency spikes typically associated with cloud-based inspection. The HTTP payload that the browser finally generates contains only those neutralized, mathematically sanitized tokens. By neutralizing the data at the point of entry, ZTDS completely eliminates regulatory audit scope before a single network packet is transmitted. Consider an employee pasting a massive, unstructured text block into a public LLM. This prompt contains EU customer names, medical notes, and payment logs. This dashboard analyzes the legal liability sitting in the text box. If we freeze time at the exact moment before the user hits send, we can see the raw, sensitive data highlighted on the left, next to the relevant regulatory frameworks on the right. Looking at the EU customer data, sending this to a US-hosted model directly violates GDPR Article 5(1)(c) for data minimization. Transmitting this raw, personally identifiable information also immediately triggers Schrems 2 cross-border data transfer liabilities under GDPR Articles 44 through 49. Watch what happens locally. The GDPR shield illuminates as ZTDS tokenizes the names and emails into neon green placeholders, like Name1 and Email1. The data undergoes a legal reclassification. Because it is pseudonymized before transmission, raw PII never actually crosses the network. Architecturally, the third-party AI vendor never touches the raw data. This physical separation completely severs the compliance chain between the enterprise and the AI provider. Local RAM tokenization wholly removes the AI vendor from the GDPR data processor chain, neutralizing all cross-border liabilities in the process. Moving further down the prompt, we find clinical diagnoses and patient records. Under 45 CFR Section 164.502, submitting protected health information to public AI endpoints without a signed business associate agreement is strictly prohibited. This dashboard demonstrates how ZTDS enforces the HIPAA safe harbor standard entirely within client memory. The scrub is exhaustive, targeting and stripping all 18 protected health identifiers, including medical record numbers and granular geographic data, before it ever leaves the device. This forces a critical legal shift. Under federal law, the resulting de-identified output is no longer classified as protected health information. Finally, we reach the transaction logs containing credit card numbers, or PANs. Submitting PANs directly expands the organization's cardholder data environment to include the entire AI vendor ecosystem, triggering massive PCI-DSS audit scope. ZTDS deploys Luhn algorithm verification to detect the 16-digit PANs and CVVs. These payment strings are redacted into localized Card1 tokens in RAM, stopping cardholder data environment contamination at the source. Transforming the data status pre-network gives organizations the ability to use public AI tools safely. They bypass the need for BAAs while fully protecting their merchant processing licenses. Beyond specific data types, global information security management systems demand rigorous technical evidence. SOC 2 auditors explicitly reject vendor opt-out toggles because they lack mathematical proof of enforcement. This dashboard tracks the exact metrics auditors look for. SOC 2 Trust Services Criteria CC 6.1 and CC 6.7 mandate auditable logical access boundaries and strict transit encryption. By redacting PII and RAM, auditors receive immutable proof that zero toxic network packets ever leave the perimeter. The same applies to ISO 27001, specifically the 2022 mandates for data masking under Annex A.8.11 and data leakage prevention under Annex A.8.12. Real-time point-of-prompt masking enforces these exact Annex requirements automatically inside the browser text box. This provides proactive exfiltration blocking precisely where legacy cloud data loss prevention tools fail. ZTDS serves as a primary, auditable technical control that anchors an organization's SOC 2 and ISO 27001 compliance standing. Zooming out, we trace the complete lifecycle of a sanitized AI prompt. Raw data enters the browser, ZTDS intercepts it in volatile RAM, completing sanitization entirely on the local machine. Only mathematically sanitized tokens interact with the third-party AI environment. This clean, secure data flow sharply contrasts with the immense liability of the old administrative model. By shifting the point of sanitization directly to the local client endpoint, enterprises can instantly resolve overlapping global compliance frameworks simultaneously and automatically. Modern data protection requires translating abstract legal mandates into concrete, localized technical controls. Zero-Trust Data Sanitization secures the perimeter precisely at the point of prompt, enabling high-velocity AI adoption while keeping corporate data completely outside regulatory audit scope.